What if I told you, a single machine can shatter solid rock like glass in seconds underground? We stand inside deep construction sites where steel meets stone with unstoppable hydraulic force every second. Most people never see the brutal power hidden inside this compact metal hammering machine. Inside this machine, pressurized oil transforms into raw destructive force beyond human imagination. Imagine a hammer striking stone thousands of times per minute without ever slowing down. And here's what nobody tells you. The same force that builds cities also destroys mountains. These machines don't just break rock, they reshape entire landscapes for human progress. But before we see how it's built, we must trace where its strongest materials come from. Every hydraulic breaker begins deep underground where iron ore is pulled from ancient rock layers. This iron travels thousands of kilometers from mines in Australia, Brazil, and India to massive steel plants. At steel plants, ore is heated above 1,500 degrees Celsius until it melts into glowing liquid metal.
The molten steel is purified, removing carbon and impurities until it becomes high-strength alloy steel.
Then steel is cooled into massive blocks weighing several tons each for industrial shaping. These steel blocks are transported to machining factories where precision shaping begins. CNC machines carve the breaker housing with micrometer-level precision using computer-guided tools. Every cut must be perfect, because even a 1 millimeter error can destroy the entire breaker system. Now we enter the world of robotics, where hydraulic breakers are assembled with precision machines and human control. Each hydraulic chamber is tested under extreme pressure exceeding 200 bar without a single leak allowed. If even a microscopic crack appears, the entire unit is instantly rejected by automated inspection systems. Laser scanners measure tolerances down to 0.01 millimeters, ensuring every component fits perfectly. But here's the twist. Human engineers still perform final adjustments that machines cannot replicate. Every breaker then undergoes a brutal endurance test simulating years of real construction impact. Temperatures inside the system can spike beyond 120 degrees Celsius during continuous operation. And in one final test, engineers push the machine until it fails or proves itself unbreakable. But now we return to where every journey ends, when raw power becomes a finished machine. Across the world, over 1 million hydraulic breakers operate daily in mining, demolition, and large construction projects. The global market for hydraulic breakers is valued at over $5 billion and still rapidly growing. China, the United States, Germany, Japan, and India dominate production and usage across heavy industries. More than 200,000 engineers, technicians, and workers support this global hydraulic breaker industry. Hydraulic breakers first appeared decades ago, but modern versions are 10 times more powerful and efficient. In the next 10 years, AI-controlled breakers may automatically adjust force based on rock density in real time. Did you know some breakers strike up to 1,000 blows every single minute during peak performance? And some models can break reinforced concrete blocks that even explosives struggle to crack efficiently. But now we return to where every journey ends, when raw power becomes a finished machine. The next time you hold one of these in your hands, remember it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into what product you'd like to explore next, like this video, subscribe to the channel and we'll see you inside the next.